Today we're going to talk about inverse variation. So remember that when we're finding the inverse of a function, we first switch x and y, and then we solve for y. So I'm going to start out, this f of x, remember that that's the same thing as y. So if I switch x and y, I get x equals y to the 1/3 all over 5. And I want to get rid of that fraction, so I'm going to multiply each side by 5. So I have 5x equals y to the 1/3. And as a reminder, y to the 1/3 is the same as the cubed root of y. That's what that is. So in order to get rid of that cubed root, I have to raise both sides to the third power. So I'm going to raise this to the third power, and I get 5 cubed, x cubed equals y. But I can't leave it like that. 5 cubed is 125, so I get 125x cubed is y, or f inverse of x equals 125x cubed. The next question is the fifth root of x plus 4. So I'm going to switch x and y. So I get x equals the fifth root of y plus 4. And then I'm going to get rid of that fifth root. So I raise both to the fifth power. So I get x to the fifth equals y plus 4. Subtract 4 from both sides. And I get x to the fifth minus 4 equals y, or f inverse of x equals x to the fifth minus 4. Similarly, so the next problem is a little bit more difficult. So I start out, I'm going to switch x and y. So I have x equals 9 times the fifth root of y plus 5. I'm going to start out by getting rid of that 9. So remember, when we're doing inverse operations, we have to start with what's outside of the parentheses. So I'm going to divide by 9. So I have x divided by 9 equals the fifth root of y plus 5. Then I'm going to subtract 5. So I have x divided by 9 minus 5 equals the fifth root of y. And then I'm going to raise both of these to the fifth power. Remember, I'm going to raise everything to the fifth power. So I get parentheses x minus 9 minus 5, all raised to the fifth power. So my f inverse of x is x divided by 9 minus 5, all raised to the fifth power. Next, I have the cubed root of x plus 1 all over 7. So switch x and y. X equals the cubed root of x plus 1 all over 7. Sorry, not x plus 1, y plus 1. I'm going to get rid of that denominator first. Multiply both sides by 7. So I have 7x equals the cubed root of y plus 1. Get rid of that cubed root, so I'm going to raise everything to the third power. So I have 7 cubed x cubed equals y plus 1. And then I'm going to subtract 1. Now I can't leave that 7 cubed. I have 7 cubed x cubed minus 1. I have to actually know what 7 cubed is. So 7 cubed is 343. So this is 343 x cubed minus 1. So f inverse of x equals 343 x cubed minus 1. Again, switch x and y. So if x equals y to the 1/3 minus 1 all over 9. Get rid of my fraction here. Multiply both sides by 9. So I have 9x equals y to the 1/3 minus 1. Add 1. So I have, do this over here, 9x plus 1 equals y to the 1/3. And remember that y to the 1/3 is the same as y, the cubed root of y. That's the same. So I'm going to raise both of these to the third, both sides to the third power. So I get both cubed, and you get the quantity 9x plus 1 cubed is y, or the quantity 9x plus 1 cubed is f inverse of x. Now inverse variation. So inverse variation, inverse proportion occurs when one value increases and the other decreases. So for example, I've got xy equals k, or x equals k divided by y. So if p is inversely proportional to the square of q, and p is 16 when q is 11, determine p when q is equal to 4. So inversely proportional means p1 q1 equals p2 q2. Okay, so inversely proportional, you're going to multiply those both together. Okay, so p1 q1 equals p2 q2. Now the square of q, that means q squared. Okay, the square of q. If you were looking for the square root, it would say the square root of q. So make sure you know that. So I have this equation, p1 q1 equals p2 q2, and it says they're proportional to the square of q. So that means that I've done this down here. p1 squared, q2 squared. Okay. Then it says, and p is 16, so p is 16, so I replaced p2 with 16, when q is 11. So when q is 11, so I changed that also to 11. Determine p when q is equal to 4. So then we took over here, right there, q is 4. So I'm going to solve for this. So I have p1, 4 squared is 16, equals 16 times 11 squared is 121. So this is 16 times 121. Or p1 times 16 equals 16 times 121 is 1,936. So I have to solve for p1. I divide both sides by 16, and I get 121. So the answer here is p1 equals 121. You're just solving for p. So let's do, if p is inversely proportional, so remember that's what this was up here, inversely proportional. If p is inversely proportional to the square of q, okay, so we've got p1 q1 equals p2 q2. That's the inversely proportional part. To the square of q, so that means that these are both squared. That's what the square of q. And p is 16. P is 16. So I'll put that here. P is 16. When q is 9. So when q is 9. So I'm going to put that there. So p is 16 when q is 9. Determine p when q is equal to 4. So that would be times 4 squared. So I have to just solve for p2. So this is 16 times 9 squared is 81 equals p2 times 16. So 16 times 81 is 1,296 equals p2 times 16. Divide both sides by 16. And I get 81. Now, P and Q vary inversely. So there was inversely proportional, and now we're looking at vary inversely. So when you vary inversely, you end up with P1 Q1 equals P2 Q2. Oh, no, we had, sorry, inversely proportional, vary inversely. So we get P1 Q1 equals P2 Q2. So P is 10. They just say that they're vary inversely. So we've got P is 10. Whoops, didn't do it there. P is 10. When Q is 14. Determine Q when P is equal to 7. Okay, so we simplify this. We have 7 times Q1 equals 140. Divide by 7. And 140 divided by 7 is 20. So Q1 equals 20. So P and Q vary inversely. Okay, so vary inversely. And P is 4 when Q is 7. So I have P1, Q1 equals P2, Q2. I know that P is 4 when Q is 7. Determine Q when P is equal to 2. So I'm going to plug those all in. So I have 4 times 7 equals 2 times Q2, or 28 equals 2 times Q2, divide by 2, and 14 is Q2. P and Q vary inversely. So P1 Q1 equals P2 Q2. And P is 24. So P is 24 when Q is 23. Determine Q when P is equal to 2. So I have 24 times 23 equals 2 times Q2. So 24 times 23 is 552 equals 2Q2. Divide by 2. And you get 276. So you have Delta Math homework. Good luck.